Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 22, Stoichiometry Part 3. Here are our objectives for today's video. Pause here. So when we talk about percent composition, we're almost always going to be talking about mass percent because that is more practical because those things can actually be measured, whereas mole percent is much more difficult to measure, though there are ways to do it, just not directly. Pause here. I'll work through it. This one should be pretty straightforward. So carbon dioxide has a formula of CO2 and a molar mass of 44 grams per mole, I think. Yeah, 44 grams per mole. So for the mass percent of carbon is just the fact that 12 of those 44 grams are coming from carbon. The overall is 44. That is 27%. This isn't a sig fig problem. I could have rounded that differently if I wanted to. But then the percent by the percent of atoms is really just 1 over 3 because there's 3 atoms in there. Only one of them is carbon, so that's 33%. Pause here. So just a very similar problem, just with a more complex chemical formula. So before I do anything, I need the molar mass. These aren't sig fig questions, but just for your own peace of mind, I would suggest that you keep everything consistent. So here, since I just picked the 10th place, I'm going to just keep everything to the 10th place. The reason why I suggest you keep everything rounded to the same place is because once you've done a problem, if you're doing it for each element, if you add it all together, make sure it adds up to 100%, then you can be pretty certain that you got the right answer. Pause here. So empirical and molecular formulas is just the difference between simplified and not simplified formulas. So everything that is type 1 or type 2 is it's empirical and its molecular are more or less the same, although we don't really refer to ionic things as being molecules anyway. But for things that are covalent, which isn't just limited to type 3s and acids, there's a bunch of other types of covalent compounds. Those have typically different molecular formulas than they have empirical. For example, benzene, its molecular formula is C6H6, whereas its simplified formula is CH. So the empirical molecular formulas will have the same percent composition. The only difference will be the molar mass. Pause here. So if you're trying to determine the empirical formula, there's a process, and there's many ways to do it. I just really like this method. You start by assuming that you have 100 grams of the substance. You determine how many moles of each that you'd have, and then we look for the ratio of moles. Let's look at an example of this. Pause here. All right. So I'm going to assume that I have 100 grams, meaning I've got 82.2 grams of nitrogen, and I've got 17.8 grams of hydrogen. Next, I'm going to convert these to moles. Now I'm going to look for the ratio of these. So it's typically easiest if you take the larger of the two numbers and you put it over the smaller of the two numbers, but there's more than one way to do it. When I put it in my calculator, I got 3.03. That is approximately equal to 3. So that means I've got approximately 3 hydrogens for every 1 nitrogen. So this is NH3. That is all I have for you tonight. Thank you so much for watching and have a good night.